Oh, hello. I'm Mr. Pinola, and I'm here watching television. Well, not really. As you can see, there's a lot of static on this really old TV set. This TV set is a device which is able to create an energy conversion. Do you know what kind of energy conversion is happening here? Well, our TV is plugged into the wall through this wire, and so therefore it's taking in electrical energy. And that electrical energy is given off in two forms. First, in the form of light energy, as you can see from the light traveling towards me. And second, if I were to turn it up, in the form of sound energy, which is coming from the static that right now this TV is making, since it's not connected to any channels at the moment. So, our TV was taking electrical energy and converting it into light and sound energy. We can find out a little bit of information about this television if we know how quickly it converts electrical energy into light and sound energy. In other words, we should figure out what is the power rating of the television. Do you remember how to find power? There was an equation that we talked about the last time that we were together. And the equation looks something like this. Power equals I times V. In other words, if we know the electric current that's traveling through the television, and we know the voltage that it's hooked up to, we can find what the power of the television is. Luckily for us, there's some information on the back of this old TV that'll help me figure this out. So let me turn it around and we'll fill in part one of our three-step method with the information we get from the back. And I'm reading here that this television draws a current, or I, of 0.8 amps when it is hooked up to a 120 volt outlet, which is exactly what I have it plugged into right now, the outlet that's next to my computer. So we can certainly find the power now that we know the current and the voltage from the information that was on the back. Let's do that. I'll take out my calculator. And if I do I times V, 0.8 times 120, I'm finding that the power of this particular model of television is exactly 96 watts. So the power of our old television is 96 watts. Now, I'm going to take that measurement and I'm going to focus on the units. Do you remember what watts stood for? Well, they stand for joules per second. So in other words, the power of this television is really 96 joules per second. That makes sense as an energy conversion device. The television is converting 96 joules of energy every second. So every second that I leave it on, it's taking 96 joules of electrical energy and converting it into 96 joules of light and sound energy. But let's stick with power for the time being measured in watts. And we're going to use this scale. King Henry died by drinking chocolate milk. That's how I remember it. To convert from the base unit of watts, that's why I'm pointing to the B, into the non-SI unit of kilowatts, abbreviated with a K. To do that, we're going to slide our decimal 3 places to the left. So instead of 96 watts, we're going to take our decimal, move it 1, 2, 3 places, and we will end up with a new value of 0.096 kilowatts. It might not make a whole lot of sense right now why I converted the power from SI units into the non-SI units of kilowatts, but you'll see in just a second. According to our calculation, the information on the back of the TV, and our unit conversion, our old television, which you still barely see in your picture here, has a power rating of 0.096 kilowatts. So what can I do with that information? The fact that the TV uses 0.096 kilowatts of power. Well, there are many power companies or electrical power companies throughout the United States. Norwood Light is a company that we have in town. National Grid is a company that exists throughout the country. Maybe you know of a local power or electrical service provider in your town. Well, electrical power is charged by the electrical company. They charge you not for power, but for how much energy you use. For example, let's say that an electrical power company charges you 12 cents, so $0.12 per kWh. That stands for 12 cents per kilowatt hour. Now remember, kilowatts was a unit of power, but kilowatt hours is actually a unit of energy. So the power company charges you for energy that you use, not for the power that you use. Let's see if we can use this concept, the idea that the local power company is charging us 12 cents per kilowatt hour, and figure out how much I would have to pay to operate a TV like this one. So it's a lazy, rainy day outside, or month, let's say, and I'm watching my old school television, let's imagine, for 8 hours a day. At least that's how long I leave it on for. Hopefully you're not watching that much television. Well, that means that the time that the television is on for is 8 hours. And do you remember what the power of our television was? Well, the power of our television was 0.096 kilowatts. Remember, because we made that conversion. The electric company is going to charge us for the energy that we use. Do you remember what unit the electric company measured energy in? It was a strange one. It wasn't in joules. They charge us per kilowatt hour. So, how can we calculate the energy that I use in a single day using my 0.096 kilowatt television? To do that, we have to see that kilowatt hours as a unit is essentially kilowatts times hours. So we can figure out that the electrical energy that we convert is equal to just the power measured in kilowatts multiplied by the time in seconds. Let's do that calculation now for our TV if we leave it on for 8 hours. So 0.096 kilowatts times 8 hours gives me an electrical energy consumption of 0.768 kilowatt hours. Remember how we said that the electric company will charge us 12 cents per kilowatt hour of energy that we use? Well, that's a relatively standard rate these days for electrical energy charges. So if I use 0.768 kilowatt hours in one day, how much would I have to pay for that? Well, it's 12 cents per kilowatt hour. So I would take that electrical energy that I used, 0.768, and multiply by 12 cents. So 0.768 times 12 cents gives me a cost for this particular TV, if I was to watch it for 8 hours each day. That would give me a cost of $0.09 or 9 cents per day. Action 1. So how much for the month? If I watch my TV, or at least leave it on, for 8 hours per day for an entire 30-day month, to find my cost, all I would do is take my cost per day and multiply by 30. In this case, 9 cents or 0.09, which there might be some decimal places after that, but we rounded to the nearest cent, would be $2.7 or $2.70. So if you leave your TV, if it's a TV like this one, on for 8 hours a day for an entire month, you will end up having to pay $2.70 approximately to the electrical company in order to run that TV. $2.70, you're saying. So wait, why are your parents then telling you that you should turn off the TV or turn off your devices because you're wasting electricity? That doesn't seem like all that much to some people. But the problem is there's a lot of other factors that add together, resulting in potentially a really big electric bill. For example, let's say that you operate an air conditioner for 8 hours a day. Well, air conditioning units, even if it's just one of the window variety, use maybe 10 times the amount of energy that your television does per hour. And so if it costs you $2.70 to run your television for 8 hours per day, then maybe it would cost you $27 to run the AC in that way for a month. And then we have your refrigerator that's plugged in, that's running 24 hours a day. So maybe depending on the cost of the energy efficiency of your refrigerator, maybe you pay another $30 to run the fridge. Maybe you pay another $10 to run all of the various lights in your house, which have different power ratings and you leave on for various amounts of time. As you can see, these numbers add up pretty quickly, resulting in pretty high monthly electric bills for some people if they're not careful. So let's look at the difference between running our old school television that we've been focusing on and running an air conditioning unit. Let's say the air conditioning unit has 10 times the power that the TV does. So 96 watts versus 960 watts. 960 watts is actually a very efficient air conditioner. A lot of the units will use a higher power rating than that. So this is even on the low end. But as you can see, if I operate the TV for 8 hours a day for 30 days in a month, it's going to cost me a certain amount. But running the air conditioner, this air conditioner converts more energy per second. More joules of energy are converted per second using the air conditioning unit. And therefore, I use more total energy each second than I do using the television. In fact, because the air conditioning's power rating is 10 times that of the television, it uses 10 times as much energy per second. And that means the cost of the air conditioner is going to be 10 times as much. So that's why you might want to pay attention to the information on the back of some devices that you purchase. The lower the power rating, the less amount you're going to pay per second. And if the device doesn't tell you the power rating, you can always calculate it, just like I did with our television set. But how does the electric company know how much to charge you for electricity? There's not somebody sitting in your house saying, oh, they left the lights on, I'm going to charge them this much for the extra time. No. Instead, you likely have a box like this, somewhere outside of your house. And on that box, there are probably 5 little dials like you see here. Some modern day boxes are digital, so it might give you a readout that you can just read the number. But a lot of boxes have little dials, and there's a little piece in the middle that spins. If you're at home, maybe go take a look at yours. You'll see that there's a disc in the middle that's spinning around. That shows that you're generating electricity, and that disc will spin faster the more electricity you use. In any case, these little dials will give you a reading as to how much electrical energy you've used. But to read the dials, it's a little bit tricky. So let's go through that before we go any further. So here is a close-up of an electrical meter that has read a household has used a certain number of kilowatt hours, as you see written across the top. Remember, kilowatt hours is just a non-SI unit for energy. You might notice, if you look closely at the dials, that they're flipped. The first dial on the left reads like a clock. It starts out 0, 1, 2, 3, 4, 5, all the way up to 9, and then back to 0. And so you would read it in the clockwise direction. The second dial is flipped. It goes the other way. That's due to the inner mechanisms of the device. You would read this dial backwards. So what does this dial read in front of us? The first digit would be a 4. And I'll write that big on my board here. That's because going clockwise, the dial goes past the 4, but not quite up to the 5. Notice the second dial. A lot of people would be tempted to say that it should read 5 because it goes slightly past the 5. But we have to read it from the other direction, increasing our numbers. So reading the second dial counterclockwise or anti-clock, we can see that it comes out to a second digit of 4 because it is between 4 and 5, and we take the lower number. Continuing on, the next digit we read from the opposite way again. That digit is not 0, instead it's 9. The penultimate or second to last digit is a 6. That's because, again, we have to flip the direction that we make our measurement from, going 1, 2, 3, 4, 5, 6, and then not quite making it up to 7. And then finally, our last digit, we read the normal way, or the normal way, at least how we would read an analog clock. That digit is slightly past the 3, but not to the 4. So that final digit is 3. This person would have used 44,963 kilowatt hours. So now we know how to read a dial that the electric company would use to figure out how many kilowatt hours you've used. But this is an all-time total. You don't get charged every month for the total electrical energy that your house has used. What if you just moved there? That would be unfair that you keep getting charged every month for electrical energy the previous owners used. So instead, what the electrical company does is they will read your meter on a certain day. So let's say that they read this meter on June 3rd, and they get 44,963 kilowatt hours. Let's say next month, on July 3rd, they take another reading, and that reading says 45,963 kilowatt hours. They would figure out how much electrical energy you used by finding the difference between these two numbers. They would subtract your June reading, the amount that you were already billed for, from your July reading. And so in this example, there is a difference of 1,000 kilowatt hours between these two readings. At a rate of 12 cents per kilowatt hour, a person in this household would pay 1,000 times 0.12, or $120 for the time frame between June 3rd and July 3rd. So remember, while energy can't be created and it certainly can't be destroyed, the electrical company will charge you for how much energy you convert from one form into another. If your device is very powerful, like an air conditioning unit, it's probably going to convert energy very quickly. And as a result, you will accrue some pretty high bills using those devices. So if we pay attention to electrical power and how long we leave our devices on for, we can actually calculate how much our electrical bill will cost us, because the electrical company would charge us for power. No, the electrical company will charge us for energy, not for power. Thanks for watching.